Yeah, whatever, everybody. Sorry. As you can probably tell, dude, my voice congested. Let's get some tunes here to warm up the stream. All right, hold on. Sorry, y'all. I'm running slow today. It was a long day at work today. I was doing a lot of coding today at work, building my tool out the graphics and interface and everything for people to deal with, and looks really nice. I wish I could show you guys, but sadly I cannot. All right. I like this. This sounds like Delicate Steve. Any guys familiar with some Delicate Steve? I love me some Delicate Steve. Love me Delicate Steve. Welcome in, welcome in, welcome in, $100 million mindset. Struzy, welcome in, my boy. Let's get the Twitch going. We are also live on Twitch, but the party is bumping. Yes, today we're going to be jumping back in. Oh, sorry I was gone yesterday, you guys. Dude, I was super low energy. Like, I barely made it through work. I almost called out today. I was not feeling that well again this morning, but I went because I'm like, maybe I'll just kind of feel better in the afternoon. I don't want to burn a PTO day. But so we pushed through, and actually I was kind of glad I went because I was able to pretty much finalize the last little feature I needed for like additional pop-up windows on my app for my kind of my work tool, and so it works. It's really nice. We built like the entire graphics interface. It interacts. It's got really nice error handling, status updates, kind of logic blocking and stuff for making sure that users won't break it, and it works accordingly, and so everybody can use it. I guess so. If you guys are familiar, I wrote a tool for my work. I pitched to my company. I said, "Hey, I can program. Not only not only do I know some chemistry and can build these chemical products, and formulate them, but I can program as well. And so I have an idea for this math that we do by hand, that we can automate it at an even more optimized level with some algorithms, and then we can just have it be done by hand, or not done by hand, done by computer, saving us, probably upwards of like 2 whole days of computation and analysis across all hands that touch the touch time of that specific segment. And so it'll save us all that time and get you about 95% of the way with some slight tweaks that you can do as a user if you want to the numbers, and it works. It's really nice. I'm quite happy that we're able to work together with another programmer and another team from another state, or not another state, but another city, with the company, but whole different division, to come up with this. So it was really cool, and it's not done yet, but it's pretty much getting there. Light at the end of the tunnel here, and I'm quite happy with where we've got it so far. Hey, Mr. Austin, what's going on? My name is Bai. Did you end up getting a return offer from the startup you applied to? No, dude, I got denied for the one interview I did. Your boy choked so bad. I was so nervous, you guys. Like, I told this story before, but like I literally had to like start doing some push-ups and like crunches and stuff beforehand. And I don't work out, so I was so worked up. Like I like I was struggling, dude. They just asked me. They wanted a chemist that programs, a programming chemist, but they didn't ask me anything about chemistry. They just asked me only scripting questions, and then during the live coding, they gave me like kind of this more elaborate, not leak code at all, but more elaborate script to come up to do. And I mean, I think I could have done it, but just not in the amount of time they were looking for. I definitely could have done it. I got about a quarter of the way through on the first one. Maybe not even that far. And on the second problem, I think I got about like, I don't know, 75% of the way through. But it's run out of time, and I was shaking in my boots, let me tell you. It's hot in here. Let me go ahead and grab some pit. Let me go slap that on real quick. It'd be hot. All right. Yo, Kugo, Kogo. I think that's how you pronounce it. How's it going? All right, let's get the tunes off here. Let's get diving into the actual stream here without further ado. I'm gonna do a little intro for the recording. As you guys know, I'm recording a condensed version where like I chop up all the kind of discussion and note taking into more just a read along. So if you're interested in following that along, like as if you're in the car, like I think it's a great opportunity to like listen to the book. As you're just kind of subliminally doing things or whatnot. Like, yeah. So yeah, feel free to check those out. But you can obviously look back to these streams to get the full picture of what we talked about in the chapter here. So chapter 2 is a little bit longer than chapter 1, but I think we'll be able to get through it here in maybe like an hour and a half. Hopefully, that's my goal. I don't want to really have to record and chop up more than that, so we got to get moving here. Anyway, so let's go ahead and get started. I'm going to go ahead and scroll back up to the top here so I can just get a intro. Bear with me, the cringe here. I'm sorry. Just got to do an intro. All right. Hello, everybody. We are back here in C Programming, a Modern Approach, 2nd edition by K.N. King. We're going to be jumping back into Chapter 2 today, or starting Chapter 2, rather. I got to restart that. That was trash. All right. Hello, everybody. We are back. No, I just peeked the mic. Hello, everybody. We are back. I appreciate you guys for joining me. Welcome, welcome, welcome. We are going to be jumping back into C Programming, a Modern Approach, 2nd edition by K.N. King. This is going to be a rough go. C Programming, a Modern Approach, 2nd edition by K.N. King. We're going to be starting Chapter 2 today and hopefully completing it. Thank you guys so much for being here. Let's go. Hold on. Let me scroll to find where we're at. I'm choking, you guys. Choking under the pressure. Come on. Focus. Oh boy. It is a longer chapter. We're going to be jumping back into Chapter 2 today. Or, we're not jumping back. We're going to be jumping in. We're going to be starting Chapter 2, C Fundamentals. Thank you guys so much for being here. This is the condensed version on the channel. If you'd like to check out the full picture stream, you can go ahead and watch the stream where we talk and do notes, discussion, and complete the practice problems live. All right, let's go ahead and get started in Chapter 2, Fundamentals. Oh my God. All right. Hey, Amar, how's it going? Hey, how's it going? Shaunuk, welcome back in. I appreciate you joining me again. Kogo, we're learning C. It's a great... I kind of have a little bit of a fluency in Python at the moment. I'm kind of getting better. I'm getting more and more better. I'm getting better at it every day. And I want to, understand why my Python works. And so we're going to be jumping into C and hopefully maybe writing some more advanced scripts in C as we kind of manipulate maybe hardware and get like an Arduino and microcontroller and start maybe diving into the hardware side of things, because I think that could definitely set us apart. Today I officially took my test and became a certified bank security manager. Boom! Austin. That's big clutch. That's big clutch. Are you a quant trader, Austin, or is that more of a more of an overarching position of like where you manage people? Okay. Let's jump in. We got to get going here. All right. Chapter 2, C Fundamentals. Let me make sure I'm recording. Yes. One man's constant and another man's variable. This chapter introduces several basic concepts, including pre-processing directives, functions, variables, and statements that we'll need in order to write even the simplest programs. Later chapters will cover these topics in much greater detail. To start off, sections 2.1 present a small C program and describes how to compile and link it. Sections 2.2 then discusses how to generalize the program, and section 2.3 shows how to add explanatory remarks known as comments. Section 2.4 introduces variables which store data that may change during the execution of a program, and section 2.5 shows how to use the scanf function to read data into variables. Constants. Data that won't change during program execution can be given names, as section 2.6 shows. Finally, section 2.7 explains C's rules for creating names, identifiers, and section 2.8 gives the rules for laying out a program. Okay, so this is a little bit of a chunky section here. This is going to kind of, as it goes by the title, fundamentals. This is going to be a great chapter to come back and reference. I'm probably going to listen to myself reading this chapter, because I would like to get the fundamentals down even more. So this is going to be a great place to really hone in here. All right. 2.1, writing a simple program. In contrast to programs written in some languages, C programs require a little boilerplate. A complete program can be as short as a few lines. Program, printing a pun. The first program in Kernighan and Ritchie's classic, The C Programming Language, is extremely short. It does nothing but write the message, "Hello World." Unlike other C authors, I won't use this program as my first example. I will, however, uphold another C tradition, the bad pun. Here's the pun. To see or not to see? That is the question. The following program, which we'll name pun.c, displays this message each time it runs. So we have pun.c here. We include the standard.io.h. We remember, like, this is the standard library. And we have define a main function, which has a int main void. Inside the brackets here, printf to see or not to see, that is the question. And obviously with the printf, if we remember back, we have the delimiting character, or the new line character here. And we return 0 back to the console. All right, section 2.2 explains the form of this program in some detail. For now, I'll just make a few brief observations. The line, hashtag include the standard io.h, or stdio.h for short, is necessary to include information about C's standard I/O input-output library. The program's executable code goes inside main, which represents the main program. The only line inside main is a command to display the desired message. Printf is a function from the standard I/O input-output library that can produce nicely formatted output. The \n code tells the printf function to advance to the next line after printing the message. The line return 0 semicolon indicates that the program returns the value 0 to the operating system when it terminates. Compiling and linking. Despite its brevity, getting pun.c to run is more involved than you might expect. First, we need to create a file named pun.c containing the program. Any text editor will do. The name of the file doesn't matter, but the .c extension is often required by compilers. Next, we've got to convert the program to a form that the machine can execute. For a C program, that usually involves 3 steps. Pre-processing. The program is first given to a preprocessor, which obeys commands that begin with hashtag known as directives. A preprocessor is a bit like an editor. It can add things to the program and make modifications. Compiling. The modified program now goes to a compiler, which translates it into machine instructions, object code. The program isn't quite ready to run yet, however. Linking. In the final step, a linker combines the object code produced by the compiler with any additional code needed to yield a completed executable program. This additional code includes library functions like printf that are used in the program. Fortunately, this process is often automated, so you won't find it too arduous. Is that how you pronounce that word? I forgot. Is it arduous? Onerous? Pronunciation. It's thrown a couple of words at me here, US.
Onerous.
Onerous. Onerous. All right. Fortunately, this process is often automated, so you won't find it too onerous. In fact, the preprocessor is usually integrated with the compiler, so you probably won't even notice it at work. The commands necessary to compile and link vary depending on the compiler and operating system. Under the Unix, the C compiler is usually named CC. To compile and link the pun.c program, enter the following command in a terminal or command line window. cc pun.c. The percent character is the Unix prompt, not something that you need to enter. Linking is automatic when using CC. No separate link command is necessary. After compiling the linking program, CC leaves the executable program in a file named a.out. By default, CC has many options. One of them, the -o option, that allows us to choose the name of the file containing the executable program. For example, if we want the executable version of pun.c to be named pun, we would enter the following command: cc-o pun.c. Cool. So yeah, you can just set this name to this executable program using this command here for this compiler command. The GCC compiler. One of the most popular C compilers is the GCC compiler, which is supplied with Linux, but is available for many other platforms as well. Using this compiler is similar to using the traditional Unix CC compiler. For example, to compile the pun.c program, we would use the following command: gcc-o pun.c. The Q&A section at the end of the chapter provides more information about GCC. Integrated development environments. So far, we've assumed the use of a command line compiler that's invoked by entering a command in a special window provided by the operating system. The alternative is to use an integrated development environment, IDE, a software package that allows us to edit, compile, link, execute, and even debug a program without leaving the environment. The components of an IDE are designed to work together. For example, when the compiler detects an error in a program, it can arrange for the editor to highlight the line that contains the error. There's a great deal of variation among IDEs, so I won't discuss them further in this book. However, I would recommend checking to see which IDEs are available for your platform. Cool. That was 2.1. Let's kind of back up here, get some notes down. 2.1, writing a simple program. So we'll just write some code here. Can you just do like C? How do you do with Python? Do you go like this, Python? And then do you write like hello equals to phone equals to like print hello? I always forgot how to do this. Bar C, okay, C. And then do we do our function here? Yeah, thank you so much. Arrow, thank you. You got me. Thank you. Standard IO.h here. I can never remember these little that's the hardest part about programming, is remembering these little nuanced things. I always have to go back and look them up. Commands and stuff. Print F. So remember, you do the actual quotes like you would in Python or whatnot. Print F as in format print. And you have to be a little bit more specific. The print function in Python does a lot for you under the hood. And with this one, it's a little bit more bare bones, but it has the same kind of general concepts. So, or not to C. And then we say that is the question. And then we have to deliberately put in this \n, right, to show that we want this line to print, or the cursor in our terminal window to go to the next line. Right, the print function in Python automatically does that for us, unless we specify it not to with the end line parameter, I think, right? Or is it new line parameter? Can't remember. All right, nice. So simple little C program here, where we're just printing out to C or not to C, and then going to a new line and returning 0. Let's just jot down a few notes here. Okay, so let's go back over. No, that's nothing here we want to get. No boilerplate. We don't really need anything here. Good. Okay, well, now there are some definitions that we wanted to get here. Printf is a function. So I'll just make, and I know it might be a little bit like robust or whatever, but I want to be detailed for everybody reading these notes, and I'll just make sure that everybody is kind of on the same page. A function um, that prints formatted text um, to the terminal window. Found within the standard IO library, right? We have obviously the main function. It's kind of self-explanatory. Code goes inside the main function. \n till we'll say here we'll add the little note about the delimiter here for the \n. That's /\n. Right? Yeah. We want to say is a like special character or something like that. I don't know if that's the right word. What would you guys call it? Special character, delimiting character to indicate the cursor to move to a new line within the printf call, right? Something like that. And then the return 0, we'll just do really quickly here. Return 0. This indicates that the program returns the value 0 to the operating system. Operating when it terminates. Cool. Nice. Any other things we want to add into here? Let's just do, okay, we want to, yeah, no, these include, right? It mentioned a delimit directive, which are here down, these directives. So it mentions the directives down here. Anything else is necessary to include information about C standard IO library. We'll just add in here then a little thing about it and say the line hashtag include standard.io.h, right? We will say that this indicates that inclusion indicates inclusion of the standard IO library, a package / collection of helpful functionality, functions, or functionality, helpful, like obviously functions and methods, but like helpful tools / functions, something like that. Who was that? Who was that? Let's go to my thing here. Whoops, I gotta go to the, where are you? Streamlabs. The Streamlabs. I gotta open that up, my bad. Who was that? Must find out who was that. Right on. Thanks for the follow on Twitch. You're awesome, my boy. Did we get like a new goal or something? What was that? Like, I didn't look over. What was that like? Hey, TYD, how's it going? Intriguing stream title. Glad you like it here. Yeah, we're learning C programming. We're reading the C programming, a modern approach here. All right, for those that are new, my name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry. I graduated back in 2021, and right after school, I got a job as a formulation chemist for a biotech company, and I've been working there ever since. Kind of approaching maybe a little bit closer to like senior level chemist on my team in my group. Hopefully soon, but I am in that like mid tier, and yeah, it's been good so far, and I've been teaching myself how to code after work for about a year and a half now, starting mainly in Python and doing things like Harvard CS50X, Harvard CS50P, reading books like Introductions to Algorithms, DSA in Python, Python Crash Course. What other books have we started to read, but obviously I haven't finished. I feel like I'm missing one. Fluent Python. Yeah, we're in the middle of all those books, and we're obviously starting a new one, but this one's on C here, so we're getting into here. Hey, Grams, how's it going? Leon, my boy, welcome. Semicolon at the end of line. Ah, you're right. I'm bad at that. Thank you, Leon, for keeping me accountable. Escape sequence. Escape sequence, that's a good idea. Is a escape sequence or escape character. Escape character and escape character to indicate the cursor to move to a new line within the printf call. Right? That's a better definition. Thank you, Leon, for that polish. Hey, Grims, yes. All right. There's a Markdown VS Code extension. Oh, I might have to get that. I usually just use Shift-Command-V, and you can view it here. It looks really nice. All right, let's keep rolling. Nice. Okay, compiling and linking. Let's grab some notes here. Despite its brevity, I put on C. Doesn't matter, but extension is often required, right? So that's kind of inferred. I don't think we really need to make some notes on that. Got to convert the program. We need to convert the program to a form that machines can execute. So we'll do steps to convert some program.c to a form that the machine can execute. 3 steps. 1, pre-processing. 2, compiling. And 3, linking. So pre-processing. The program is first given to a preprocessor, which obeys commands that begin with hashtag, known as directives. A preprocessor is a bit like an editor. You can add things to the program and make modifications. I'm actually going to take this just right out of the book, I think. Yeah. It's given to a preprocessor, right? Which obeys commands that begin with the hashtag, known as directives. A preprocessor is a bit like an editor. You can add things to the program and make modifications. Beautiful. Compiling. The modified program now goes to a compiler, which translates it into machine instructions or object code, right? The program isn't quite ready to run yet, however. Cool. Oh. Compiling. I like that definition. Right out of the book. I usually like to type my own, but sometimes it's just easier when they're kind of really kind of short and to the point. The modified program now goes to compiler, which translates it to machine instruction or object code. So I'm guessing this would probably be like what? Assembly, 1s and 0s, or assembly, And then maybe not, and then assembly translates into ones and zeros or something like that, or who's got an answer for me here? I'm sure we'll learn soon enough. All right, and then finally here in linking, the final step, a linker, combines the object code. Okay, so you pre-process it, which goes through and I think does all these directives, which is these include statements. Potentially, because that's the only thing I see here starting with a hashtag. The compiling thing, right? That's what translates this kind of C code into machine instructions or object code. Yeah, we finished the CS50X course back in we started it in January and finished it in March of this year, and so we're going back and getting some more hitting some more C stuff again as it's definitely coming easier to us the second time around here. But definitely needed a second time around. That class was a little bit too quick about going through some of these kind of more. And honestly, I kind of was snoozing through some of those lectures. I was just not really that. I don't know. Not really my best way of learning, in my opinion, or at least for me. The modified program now goes to a compiler, which translates into machine instruction or object code. It isn't quite ready to run yet, however. Okay. So then we link. So this linking step combines the object code that was in the compile step to produce with any additional code needed to yield a complete executable program. The additional code includes library functions like printf that are used in the program. Okay. Like printf. That are used in the program. Okay. Is a linker. Preprocessor hashtags are preprocessing instructions. Preprocessor also does text substitution. If you have hashtag define some macro. All right, I saw that, right? So it's kind of like you can do these. I saw someone doing this on a C video I was watching where you can define kind of like these not like variables or like global variables, but like kind of like these, like you said, like these text like substitutions, and it looked kind of useful. I don't know, like instead of like inserting like global variables or whatever, it kind of like was these text, and you can put them in your own .h file and have like it really organized that way, and then import that .h file just like you would with your own standard IO or whatever. So it was pretty cool. I was watching that. We'll have to maybe do like a stream where we watch some of these videos I was watching. He's doing like more, he's like using like an Onion browser and stuff. And it was kind of cool. I wanted to maybe see if we could dive into that. I don't know. Kind of scared though. All right. Fortunately, this process is automated, right? It won't find it too onerous. Usually integrated. So the pre-processing is usually integrated with compiling. So we'll see here, typically integrated with the compiler, right? The commands necessary to compile and link vary. Okay, so now we have the CC compiler, right? So you have the CC compiler. So the CC compiler, under Unix, the C compiler is usually named CC. Under the compiler, compiler used under Unix. right? To compile and link the pun.c program, enter the following command in a terminal or command line window. So you would do like this. I guess we'll go like here and do like maybe like we'll have like example. I don't know. And you do cc file.c or yeah program.c. So yeah, file.c. Or like your file. We'll do like your file. In a command line window. Command line interface. Okay. Cool. After compiling and linking the program, CC leaves the executable program in a file named a.out by default. Okay, so the CC compiler, after compiling, and linking the program, CC leaves the executable program in a file named a.out by default. CC has many options. One of them, using the -o option, allows us to choose. Okay, so like -o option right. So the -o option allows us to choose the name of the file containing the executable program. So that you can do like, here is cc -o your file .cc. Okay, so let me just do actually like this. Okay. We'll put actually not this here, we'll do this up here like this. Okay. What's up, Mr. Film Pam? I'm taking a Scheme class at the moment. Nice. If you're on Mac, you probably use Clang or GCC compiler. Yeah, I think Clang was used in the CS50 course. If you're on Linux, CC points to GCC. On Mac, I believe CC points to Clang. GPT says Clang is superior for Mac OS. Not .cc, just .c. Oh, just error. Sorry, typo. Thank you. You guys are on me. Thank you, Blasto. All right, cool. Okay, so then we have the GCC compiler. So you have GCC. Sorry, I know these notes is kind of more, it might be a little bit more annoying than us reading. It's going to take us a little bit, but this us reading through and then going back through the section, just like that iteration and reading it through and then taking notes. It's like, some of you guys might, if you guys aren't like really familiar with like the studying, or you're trying to like learn to study, like, and you're maybe going through college, like, I highly recommend you, like, I'm not saying these are the right ways to do it, but like I did do fairly well in school and some fairly difficult, advanced, molecular biology classes and things like that, basically just having to memorize things that you don't even know exist because you have to believe they're there in a microscope, and like, and so it's like, reading these things, okay, going back through, taking the notes, and then coming back through a couple of days later to solidify, like, just stay with me here. That's how we do it around here. Okay. Um, GCC compiler. One of the most popular compilers is the GCC compiler, which is applied with Linux. Linux is compiler started. Blah, blah. Using this compiler is similar to using the traditional Unix CC compiler. The following command here. So this is the compiler supplied with Linux, but is available for many other platforms as well. So using this one would be similar, or has similar use as the CC compiler. Use handling. So like we'll have the example here of this guy. GCC-O to give it a new name, or rename the executable to whatever we want. Your file.c. Nice. Nice. Adida, yo, I'm learning from the same book. I'm on chapter 15. It's a really great book. Nice, dude. You're way ahead of me. Guys, yeah, we got a long ways to go. We'll catch you, though. We'll catch you. No, you're awesome, man. Thanks so much for coming in. I appreciate you. Adida. EB. Were we learning Python? Yes. People, I don't know. I don't know. Why does everybody have this kind of like conception that if I am learning C, I'm like not learning Python? I feel like the two are very much like intertwined in the fact that, yes, I've been kind of gaining a lot of fluency in Python, but I'm not just going to lose it all by learning C. In fact, I think I'm going to get better at Python by learning C in a sense, just in an overall programming knowledge, and like, yeah, I might like have a little bit of like a minor negative effect, but like I think the overall trend will project us greater. And obviously, we're going to keep coding in Python. I mean, all my work projects and stuff are in Python and stuff like that. So, okay. IDEs. I'm not going to go about IDEs. Let's keep going here. Everybody knows about IDEs. I think that's fine. Okay, here we go. 2.2. Finally. Man, the general form of a simple program. Here we go. Let's take a closer look at pun.c and see how we can generalize it a bit. Simple C programs have the form, directives, int main, void, statements. In this template, and in similar templates elsewhere in this book, items printed in Courier appear in a C program exactly as shown. Items in italics represent text to be supplied by the programmer. Notice how the brace is shown where main begins and ends. C uses open curly braces and closed curly braces in much the same way that some other languages use words like begin and end. This illustrates a general point about C. It relies heavily on abbreviations and special symbols. One reason that C programs are concise or less charitably cryptic. Even the simplest C programs rely on three key language features: directives, editing commands that modify the program prior to compilation; functions, named blocks of executable code, of which main is an example, and statements, commands to be performed when the program is run. We'll take a closer look at these features now. Oh, thank you so much for the follow here, Michael. You're the best. Nice name, my boy. Hey, Lobo Wolf, thank you also for the sub on YouTube. You're awesome. Let me go back because I think that might have interrupted. We'll take even the simplest C programs rely on these three key language features: directives, editing command lines that modify the program prior to compilation; functions, name blocks of executable code of which main is an example; and statements, commands to be performed when the program is run. We'll take a closer look at these features now. Directives. I got that drink. Whew. If you guys are enjoying the stream, if you could leave a little thumbs up, I'd really appreciate that. We got 28 people here. Sorry my voice is a little bit nasally. I'm coming over a cold here. That's why I wasn't streaming yesterday. Let's keep chugging. Directives. Before a C program is compiled, it is first edited by a preprocessor. Commands intended for the preprocessor are called directives. Chapter 14 and 15 discuss directives in detail. For now, we're interested only in the #include directive. The pun.c program begins with the line #include standard.io.h. The directive states that the information in standard.io.h is to be included into the program before it is compiled. Standard.io.h contains information about C's standard.io library. C has a number of headers like standard.io.h. Each contains information about some part of the standard library. The reasons we're including standard.io.h is that C, unlike some programming languages, has no built-in read and write commands. The ability to perform input and output is provided instead by functions in the standard library. Directives always begin with a hashtag character, which distinguishes them from other items in a C program. By default, directives are one line long. There's no semicolon or other special marker at the end of the directive. Functions. Functions are like procedures or subroutines in other programming languages. They're the building blocks from which programs are constructed. In fact, a C program is a little more than a collection of functions. Functions fall into two categories: those written by the programmer and those provided as part of the C implementation. I'll refer to the latter as library functions, since they belong to a library of functions that are supplied with the compiler. The term function comes from mathematics, where a function is a rule for computing a value when given one or more arguments. F of x equals to x plus 1, or g of y and z equals to y squared minus z squared. C uses the term function more loosely. In C, a function is simply a series of statements that have been grouped together and given a name. Some functions compute a value and some don't. A function that computes a value uses the return statement to specify what value it returns. For example, a function that adds 1 to its argument might execute the statement return x plus 1, while a function that computes the difference of squares of its arguments might execute the statement return y times y minus z times z. Although a C program may consist of many functions, only the main function is mandatory. Main is special. It gets called automatically when the program is executed. Until Chapter 9, where we'll learn how to write other functions, main will be the only function in our program. The name main is critical. It cannot begin with start or even capital main. If main is a function, does it return a value? Yes, it returns a status code that is given to the operating system when the program terminates. Let's take another look at pun.c program. Include standard.io.h, right? And we return 0. The word int just before main indicates that the main function returns an integer. The word void in parentheses indicates the main has no arguments. The return statement, return 0, has two effects. It causes the main function to terminate, thus ending the program, and indicates that the main function returns a value of 0. We'll have more to say about main's return value in later chapter. For now, we'll always have main return value 0, which indicates normal program termination. If there's no return statement at the end of the main function, the program still terminates. However, many compilers will produce a warning message because the function was supposed to return an integer but failed to. Statements. A statement is a command to be executed when the program runs. We'll explore statements later in the book, primarily in chapter 5 and 6. The pun.c program uses only two kinds of statements. One is the return statement, the other is the function call. Asking a function call to perform its assigned task is known as calling the function. The pun.c program, for example, calls the printf function to display a string on the screen. C requires that each statement ends with a semicolon. As with any good rule, there's one exception: the compound statement, which we'll encounter later. The semicolon shows the compiler where the statement ends, since statements can continue over several lines. It's not always obvious where they end. Directives, on the other hand, are normally one line long and they don't end with a semicolon. Printing strings. Printf is a powerful function that we'll examine in chapter 3. So far, we've only used printf to display a string literal, a series of characters enclosed in double quotation marks. When printf displays a string literal, it doesn't show the quotation marks. Printf doesn't automatically advance to the next output line when it finishes printing. To instruct printf to advance one line, we must include the \n character, the new line character, the string to be printed, in the string to be printed. Writing a new line character terminates the current output line. Yeah, here we go. Thank you, Vinicius, for this sub. Appreciate you, my boy. Thank you. You're awesome. Printf doesn't automatically advance to the next output line when it finishes printing. To instruct printf to advance one line, we must include \n, the new line character, in the string to be printed. Writing a new line character terminates the current output line. Subsequently, output goes onto the next line. Y'all killing me with the subs. I appreciate it. It's kind of hard with to read though, because we got to chop this back. Writing a new line character terminates the current output line. Subsequent output goes onto the next line. To illustrate the point, consider the effect of replacing the statement by two print calls instead, right? The first call of printf writes to see or not to see. The second call writes that is the question and advances to the next line. The net effect is that the same of the printf of the original statement. The user cannot tell the difference. So unlike Python, where when you call two separate print statements and the new line character is kind of inferred in the back end of the function, with this, you can call it like this and it continues on the same line until it reaches this. The new line character can appear more than once in a string literal to display the message, brevity is the soul of wit. Shakespeare. We could write printf, brevity is the soul of wit, \n, space, dash, Shakespeare, \n. 2.3 comments. Okay, cool. That was 2.2. I kind of want to keep reading because I don't want to we've already at 47 minutes here. I'll kind of will go back through and get some notes if we have some time at the end here, but definitely probably in the next stream for sure. But I want to keep reading. 2.3 comments. If it was something like really new, and I'd probably get some notes. Exactly, Blasto. We can make Pythons. We can override that parameter. Exactly, right? All right. 2.3 comments. Our pun.c program still lacks something important: documentation. Every program should contain identifying information, the program name, the date written, the author, the purpose of the program, and so forth. Comment right now if you put your name, date, and all that stuff in your programs. Are you got clean code, boys? In C, this information is placed in comments. The symbol /* marks the beginning of a comment, and the symbol */ marks the end. Comments may appear almost anywhere in a program, either on separate lines or on the same line as another program text. Here's what the pun.c might look like with comments added at the beginning. Comments may extend over more than one line. Once it has seen the opening symbol, the compiler reads and ignores whatever follows until it counters the closing symbol. If we would like, we can combine a series of short comments into one long comment like this. Comments like this can be hard to read, though, because it's not easy to see where the comment ends. Putting these characters on a line by itself helps. Even better, we can form a box around the comment to make it stand out. Now we're getting crazy. Programmers often simplify box comments by omitting the three sides. A short comment can go on the same line with other program code. A comment like this is sometimes called a winged comment. Man, let me go step to the bathroom really quick. Man, I'm getting wrecked by this cold. I'm like blow my nose and stuff. A lot of talking here. Grab my water bottle. A lot of yapping. All right. Hey, Lance, how's it going? Ray, my boy, welcome in. Pixel, how's it going? Okay. Forgetting to terminate a comment may cause the compiler to ignore part of your program. Consider the following example. Printf, right? My cat, and you forget to close the comment, and so it ends here. C99, because we neglected to terminate the first comment, the compiler ignores the two middle statements, and the example prints only my fleas. C99 provides a second kind of comment which begins with the / or / two adjacent slashes. This is a comment. This style of comment actually automatically ends at the end of a line. To create a comment that's more than one line long, we can either use the older style, opening and closing symbols, or just put a / at the beginning of each comment line. The newer comment style has a couple of important advantages. First, because a comment automatically ends at the end of a line, there's no chance that an unterminated comment will accidentally consume part of a program. Second, multi-line comments stand out better thanks to the / that's required at the beginning of each line. Whew, man, this cold is wrecking me, guys. I don't really feel like that bad anymore. Like I was feeling pretty rough yesterday, but reading here, I'm getting even more congested. Sorry, you guys. Thank you for hanging with me here as we read chapter 2. Like the shirt, Tim. I know, had to rep it, eh? Repping it, huh? Kissing a little booty today. Okay, 2.4, variables and assignments. Right, we're going to go back through and get some notes of these. It's not really that hard of notes. It's just comments and general simple stuff. So we'll go back through. 2.4, variables and assignment. Few programs are as simple as the one in section 2.3. Most programs need to perform a series of calculations before producing output, and thus need a way to store data temporarily during program execution. In C, as in most programming languages, these storage locations are called variables. Types. Every variable must have a type, which specifies what kind of data it will hold. C has a wide variety of types. For now, we'll limit ourselves to just two, int and float. We know those. Choosing the proper type is crucial, since the type affects how the variable is stored and what operations can be performed on the variable. This is something about Python that I think I've come to actually dislike. I have found myself oftentimes using type hints now that I've kind of learned them because of how useful it is to know the type of an object, especially as you continue like pass it downstream through things. And then like you have to in Python sometimes go all the way back to where it was first instantiated to understand what the type of the object is as you defined it. And so I really am looking forward to actually having these types be defined on purpose here. Um, The type of a numeric variable determines the largest and smallest numbers that the variable can store. It also determines whether or not digits are allowed after the decimal point. A variable of type int, short for integer, can store a whole number such as 0, 1, 392, or negative 2553. The range of possible values is limited though. The largest int value is typically 2,147,483,647, but can be as small as 32,767. A variable of type float, short for floating point, can store much larger numbers than an int variable. Furthermore, a float variable can store numbers with digits after the decimal point, like 379.125. Float variables have drawbacks, however. Arithmetic on float numbers may be slower than arithmetic on int numbers. Most significantly, the value of a float variable is often just ooh. Hey, thanks so much for the sub, Jules. Appreciate you on YouTube. A variable of a type float, short for floating point, can store much larger numbers than an int variable. Furthermore, a float variable can store numbers with digits after the decimal point, like 379.125. Float variables have drawbacks, however. Arithmetic on float numbers may be slower than arithmetic on int numbers. Most significantly, the value of a float variable is often just an approximation of the number that was stored in it. If we store 0.1 in a float variable, we may later find that the variable has a value such as 0.099999987, thanks to rounding error. Declarations. Variables must be declared. Described for... Oh my gosh, dude. My mouth feels like a desert. You guys can tell by my voice. I'm like... I can definitely hear it. You guys probably can too. Sound like Squidward. SpongeBob. What's something Squidward says? I don't know. Okay. Whew. Variables must be declared, described for the benefit of the compiler before they can be used. To declare a variable, we first specify the type of the variable and then its name. Variable names are chosen by the programmer, subject to the rules described in section 2.7. For example, we might declare variables height and profit as follows. Int height, float profit. The first declaration states that height is a variable of type int, meaning that height can store any integer value. Meaning that height can... Oh, thank you all for the subs. I appreciate the subs. Might have to, unfortunately. I might have to take that off, though, while we read. But I want to make sure everybody gets their sub mentioned. Dilemmas. Oh, thank you so much. I appreciate you, 4002JJ. You're the boy. You're the man. The first declaration states that height is a variable of type int, meaning that height can store an integer value. The second declaration says that profit is a variable of type float. If several variables have the same type, their declarations can be combined. Nice. Notice that each complete declaration ends with a semicolon. Our first template for main didn't include any declarations. When main contains declarations, these must precede statements. As we'll see in Chapter 9, this is true of functions in general, as well as blocks. Statements that contain embedded declarations as a matter of style It's a good idea to leave a blank line between the declarations and the statements. In C99, declarations don't have to come before statements. For example, main might contain a declaration, then a statement, and then another declaration. For compatibility with older compilers, the programs in this book don't take advantage of this rule. However, it's common in C++ and Java programs not to declare variables until they're first needed, so this practice can be expected to become popular in C99 programs as well. Assignment. A variable can be given a value by means of assignment. For example, the statements height 8, length 12, and width equal to 10. Assign values to height, length, and width. The numbers 8, 12, and 10 are said to be constants. Before a variable can be assigned a value or used in any other way for that matter, it must first be declared. Thus, we could write int height, height equals 8, but not height 8, int height. A constant assigned to a float variable usually contains a decimal point. For example, a profit is a float variable. We might write profit equals to 2150.48. It's best to append the letter F for float to a constant that contains a decimal point if the number is assigned to a float variable. So they put an F here at the end. Interesting. Failing to include the F may cause a warning from the compiler. An int variable is normally assigned a value of type int, and a float variable is normally assigned a value of type float. Mixing types, such as assigning int and float to a variable or assigning float to a value of an int variable, is possible but not always safe, as we'll see in section 4.2. Once a variable has been assigned a value, it can be used to help compute the value of another variable. So we can do some math here to compute the volume of these dimensions. In C, star represents the multiplication operator, so this statement multiplies the value stored in height, length, and width, then assigns the results to the variable volume. In general, the right side of an assignment can be a formula or expression in C terminology, involving constants, variables, and operators. Printing the value of a variable. We can use printf to display the current value of a variable. For example, we write the message height h, where h is the current value of the height variable. We'd use the following call to printf. Printf, quote, height, colon, %d, \n, and then we put height. %d is a placeholder indicating where the value of the height variable is to be filled during the printing. Note the placement of the \n just after the d so that the printf will advance to the next line after printing the value of height. %d works only for int variables. To print a float variable, we use the %f instead. By default, %f displays a number with 6 digits after the decimal point. To force %f to display the p digits after the decimal point, we can put .p between the % and the f. For example, to print the line of profit equals to 2150.48 cents, we'd call printf as follows. Printf to quote profit colon space $% dot to f \n, and then insert the profit. There's no limit to the number of variables that can be printed by a single call to the printf. To display the values of both height and length variables, we could use the following call to printf. Printf height %d, length %d \n, height, comma, length. Nice. All right, cool. All right. Kind of cute. We got some haters in the comments. All right. Cool. So I think here it's going to ask us to print. I think here it wants us to write the program, but I'm gonna try to write it before looking at it here. So, but I think I might. Should I finish this one and then stop for get to 2.5? Kind of tired because I had this cold, but I kind of want to keep going. We're on 24. Chapter ends on 30 is the Q&A, exercises. Maybe we do the exercises and not this in text. I thought we'd do this in text program. Yeah, it is right here. Okay, so this says I'm too far here. Sorry, I'm getting lost. Okay, we're here. Okay, so this says program, computing the dimensional weight of a box. Shipping companies don't especially like boxes that are large, but very light, since they take up valuable space in a truck or airplane. In fact, companies often charge extra for such a box, basing the fee on its volume instead of its weight. In the United States, the usual method is to divide the volume by 166, the allowable number of cubic inches per pound. If this number, the box's dimensional or volumetric weight, exceeds its actual weight, thank you, Tran. Appreciate you, my boy. Thank you, thank you. Thank you for the sub on YouTube. Appreciate you. If this number, the box's dimensional or volumetric weight, exceeds its actual value, the shipping fee is based on the dimensional weight. The 166 divisor is for international shipments. The dimensional weight for a domestic shipment is typically calculated using 194 instead. Let's say that you've been hired by a shipping company to write a program that computes the dimensional weight of a box. Since you're new to C, you decided to start off by writing a program that calculates the dimensional weight of a particular box that's 12 by 10 by 8. Division is required by C using the / operator. So the obvious way to compute the dimensional weight would be weight equals to volume divided by 166, where weight and volume are integer variables representing the box weight and volume. Unfortunately, this formula isn't quite what's needed. Unfortunately, this formula isn't quite what we need. In C, when one integer is divided by another, the answer is truncated. All digits after the decimal point are lost. The volume of a 12 by 10 by 8 box will be 196. The volume of a 12 by 10 by 8 box will be 960 cubic inches. Dividing by 166 gives the answer 5 instead of 5.783. So we have in effect rounded down to the next lowest point. The shipping company expects us to round up. One solution is to add 165 to the volume before dividing by 166. A volume of 166 would give a weight of 331 divided by 166, or 1, while a volume of 167 would yield 332 divided by 166, or 2. Calculating the weight in this fashion would give us the following program. Okay, so I guess we'll just take a look at this program, and then we obviously have a lot of examples at the end of chapter 2 to do. So we have plenty of things to do. I was going to try to maybe do this one, but it's probably best let's just right now just get some examples, and then we'll get at the end of the chapter the typical ones. We can always come back and try to recreate these with some time. So dweight.c computes the dimensional weight of a 12 by 10 by 8 box. So we include the standard IO, and we int main void, meaning that we have a main function that's going to return an integer and there's no parameters. We declare some integer variables, height, length, width, volume, and weight. So it's all going to be integers, no floats. So height equals to 8, length equals to 12, width equals 10. So that's basically like the problem stated. We compute a volume, and then we compute the weight like it's stated in the problem. By adding the 165 ahead of time, it helps get rid of that truncation. It rounds up. Okay. It's kind of a little trick, I guess, for doing ceilings. Is this what's happening under the hood with the math.ceiling function? Printf, and it prints out the dimensions. So be the d, the dimension d, by d, by d, by d of length, width, and height. Printf for volume, and it'll print out the volume in cubic inches for the right here. And then printf for the dimensional weight, and print out the dimensional weight given here. And then it just outputs the 3 outputs that we were given. So a really easy, just basic math function here. Initialization. Some variables are automatically set to 0 when a program begins to execute, but most are not. A variable that doesn't have a default value and hasn't been assigned a value by the program is said to be uninitialized. Attempting to access the value of an uninitialized variable, for example, by displaying the variable using printf or using it in an expression, may yield an unpredictable result such as 2568 or -30891 or some equally strange number with some compilers. Worse behavior, even a program crash may occur. We can always give a variable an initial value by using assignment, of course, but there's an easier way. Put the initial value of the variable in its declaration. For example, we can declare the height variable and initialize it in one single step. Cool. In C, jargon, the value 8 is said to be an initializer. And any number of variables can be initialized in the same declaration. Int, height, 8, length 12, width 10. Notice that each variable requires its own initializer. Hey, thank you, Kyle. I appreciate you so much. That's awesome. Kyle Kiss. I like that. It's a cool like rocker name. That's a stage name. Kyle Kiss. Oh yeah. Thanks for the sub. Okay. Notice that each variable requires its own initializer. In the following example, the initializer 10 is good only for the variable width, not for height or length, which remains uninitialized. Right, in this example here, width is assigned to 10, but height and length are not assigned. You can't really infer that all of these will be equal to 10 in this statement. That's not true. Printing expressions. Printf isn't limited to displaying numbers stored in variables. It can display the value of any numeric expression. Taking advantage of this property can simplify a program and reduce the number of variables. For instance, the statement volume is equal to height times length times width. Printf, where we insert the volume variable into the print statement, could be replaced by the insertion of this variable for this function, or this kind of, I guess like lambda function or whatever, quick little math expression. Printf's ability to print expressions illustrates one of C's general principles. Wherever a value is needed, any expression of the same type will do. Oh, interesting, right? Because these are computing an integer value, and we are declaring an integer value to be inserted in this, that it does work. Okay. Again, I'm going to go back through and take some notes on these. I like to just go through and sweep and get a good read, and then go back through and get like a compounding refresher with some notes. I did take notes through the first section. It kind of just took us a little bit too long, so I wanted to keep reading, and I don't want the stream to be too long tonight. And then we might have to come back tomorrow and finish out the end of chapter problems. So But we're not going to move on in this book without completing the end of chapter problems. Like, I need to go back through my Introduction to Algorithms book and complete those chapter problems. I've been slacking, you guys. Jeez Louise. Okay, where are we at? We're on 2.5 here, reading input. We're going to go back through. Don't worry. Don't you worry. 2.5, reading input. Let me get caught up on some chats here. Hey, Max, thanks so much for coming in. Hey, Serial Curve. Is this a beginner course? I've read this book before. Nice, Serial. Yeah, we're reading this book. If you read it, yeah. I thought C++ was a pretty good language for beginners. It's fun. Nice. Um, all right. Let's keep rolling. Rolling, rolling, rolling. I think we're almost there. So we're almost there, guys. 2.5, reading input. Because the dweight.c program calculates the dimensional weight of just one box, it isn't especially useful. To improve the program, we'll need to allow the user to enter the dimensions. To obtain input, we'll use the scanf function, the C's standard counterpart to printf. The F in scanf, like the F in printf, stands for formatted. Both scanf and printf require the use of a formatted string to specify the appearance of the input or output data. Scanf needs to know what form the input data will take, just as printf needs to know how to display output data. To read an int value, we'd use scanf as follows. Scanf %d %i reads an integer value and stores it into I. The %d string tells scanf to read input that represents an integer, and I is the int variable in which we want scanf to store the input. The ampersand symbol is hard to explain at this point for now. I'll just note that it's usually, but not always, required when using scanf. Now, if I remember right, the scanf, this is giving us to the literal, not the pointer, or is this, no, because it wouldn't be star, whatever. Well, obviously we're going to get there. We're going to get there. Okay. Many of you guys have a precursor to the ampersand here. Let's hear it. Reading a float value requires a slightly different call of scanf. Scanf %f ampersand x reads a float value and stores it into x. %f works only with variables of type float, so I'm assuming that x is a float variable. The %f string tells scanf to look for an input value in float f format. The %f string tells scanf to look for an input value in float format. The number may contain a decimal point, but doesn't have to. Computing the dimensional weight of a box revisited. Here's an improved version of the dimensional weight program in which the user enters the dimensions. Note that each call of scanf is immediately preceded by a call to printf. That way, the user will know when to enter input and what input to enter. Computes the dimensional weight of a box from input provided by the user. So we include the standard I/O here. We have int main void, which is our main function, which returns an integer. It has no parameters. We declare a variable of height, length, width, volume, and weight, which are all of integer type. We print f, enter a height of a box, and we use scanf to receive a integer and assign that variable to height. We have printf, enter length of box, and we assign that variable using scanf to length, and so on and so forth. And we compute volume, we compute weight, and we return the same output as before. So this is similar in a sense to the input function in Python, but we have to receive and declare back the anticipated type of the variable of which the user is giving to us. Unlike input, which always just returns a string format, we need to anticipate what the user will be given back to us within that, next preceding, that call on that line. Okay. The output of the program has the following appearance. Inputs entered by the user is underlined. Cool. A message that asks the user to enter input a prompt normally shouldn't end with a new line character because we want the user to enter input on the same line as the prompt itself. When the user presses the enter key, the cursor automatically moves to the next line. The program doesn't need to display a new line character to terminate the current line. The dwait2.c program suffers from one problem. It doesn't work correctly if the user enters non-numeric input. Section 3.2 discusses this issue in more detail. Defining 2.6. Defining names for constants. When a program contains constants, it's often a good idea to give them names. The dwait.c and dwait2.c programs rely on the constant 166, whose meaning may not be all clear to someone reading the program later. Using a feature known as macro definition, we can name this constant. I'll just put that here. So hashtag define inches per pound 166. Define is a pre-processing directive, just as include is, so that no semicolon is at the end of the line. When a program is compiled, the preprocessor replaces each macro by the value that it represents. For example, the statement weight equals to volume plus inches per pound minus 1 over inches per pound will become weight equals to volume plus 166 minus 1 over 166, giving the same effect as if we'd written the later statement in the first place. The value of a macro can be an expression. Define reciprocal pi is 1.0 float over 3.14159 float. If it contains operators, the expression should be enclosed in parentheses. Notice that we've used only uppercase characters or letters in macro names. This is a convention that most C programmers follow, not a requirement of the language. Still, C programmers have been doing this for decades. You wouldn't want to be the first to deviate. Oh, really? I like that. All right. Okay, it's going to give us another program here. Converting from Fahrenheit to Celsius. The following program prompts the user to enter a Fahrenheit temperature. It then prints the equivalent Celsius temperature. The output of the program will have the following appearance. As usual, input entered by the user is underlined. Enter Fahrenheit temperature 212, Celsius equivalent 100. The program will allow temperatures that aren't integers. That's why Celsius temperature is displayed as 100.0 instead of 100. Let's look first at the entire program to see how it's put together. Celsius.c converts a Fahrenheit temperature to Celsius. Include standard.io.h. Define freezing point of 32.0 float. Define scale factor of 5.0 float over 9.0 float. We have int main void, float Fahrenheit and Celsius. Printf, enter Fahrenheit temperature. We're going to scan and wait for input for a float value and assign that to the Fahrenheit we defined in the float declaration here. We're going to create a Celsius, we're going to refer back to our Celsius definition variable and create a Fahrenheit less than freezing point times our scale factor, and then print out the resulting in 1 decimal point for Celsius and return 0. The statement Celsius equals to Fahrenheit less freezing point times the scale factor converts the Fahrenheit temperature to Celsius. Since freezing point stands for 32.0 float, the scale factor stands for 5.0 float over 9.0 float. The compiler sees this statement as this. Define scale factor to be 5.0 float over 9.0 float instead of 5 over 9 is important because C truncates the results when two integers are divided. The value of 5 over 9 would be 0, which definitely isn't what we want. The printf call writes the Celsius temperature. Printf Celsius equivalent is %0.1f \n Celsius. Notice the use of the %.1f to display Celsius with just one digit after the decimal point. Cool. The and captures the memory address of the variable. That's right. That's right. We needed to save it to the memory address of the variable. And then how do you dereference it? Is it star and or is that dereferencing the variable? Like, or maybe I'm getting that backwards. Sorry. It's been a while since we did CS50. Okay. We're obviously gonna go back through, guys. Don't get mad at me. Don't get mad at me. We're gonna go back through. Okay, identifiers. As we're writing a program, we'll have to choose names for variables, functions, macros, and other entities. These names are called identifiers. In C, an identifier may contain letters, digits, and underscores, but must be with a letter or underscore. In C99, identifiers may contain certain universal character names as well. Here are some examples of legal identifiers. Times 10, get underscore next underscore char underscore done. The following are not legal identifier. 10 times get dash next dash char. The symbol 10 times begins with a digit, not a letter, of course, or underscore. Get next char contains minus signs, not underscores. C is case sensitive. It distinguishes between uppercase and lowercase letters in identifiers. For example, the following identifiers are all different. Lowercase job, capital B at the end, capital O, capital OB, capital J, JO, capital JB, so on and so forth. Right, it's just going to show you that, kind of some universal rules for defining variables. These 8 identifiers could all be used simultaneously, each for a completely different purpose. Talk about obfuscation. Sensible programmers try to make identifiers look different unless they're somehow related. Since case matters in C, many programmers follow the convention of using only lowercase letters in identifiers, other than macros, with underscores inserted when necessary for legibility. Symbol table, current page, name, and address. Other programmers avoid underscores, instead using an uppercase letter to begin each word with an identifier. Symbol table, current page, name, and address. The first letter is sometimes capitalized as well, although the former style is common in traditional C. The latter style is becoming more popular thanks to its widespread use in Java and C#, and to the lesser extent C++. Other reasonable conventions exist. Just be sure to capitalize an identifier the same way each time it appears in a program. C places no limit on the maximum length of an identifier, so don't be afraid to use long descriptive names. A name such as current page is a lot easier to understand than a name like CP. Words, or keywords. Let's get comments and chats here, hold up. Star is the pointer dereference operator, got you, right. So the ampersand is the reference to reference that memory location, and star is to dereference that memory or to get whatever that object or that data point is at that memory location. That's right. Okay. Keywords. The keywords in Table 2.1 have special significance to C compilers and therefore can't be used as identifiers. Note that 5 keywords were added in C99. Because of C's case sensitivity, keywords must appear in programs exactly as shown in Table 2.1, with all letters in lowercase. Names of functions in the standard library, such as printf, contain only lowercase letters also. Avoid the plight of the unfortunate programmer who enters the entire program in uppercase, only to find that the compiler can't recognize keywords and calls the library functions. Brutal. Watch out for other restrictions on identifiers. Some compilers treat certain identifiers, ASM for example, as additional keywords. Identifiers that belong to the standard library are restricted as well. Accidentally using one of these names can cause an error during compilation or linking. Identifiers that begin with an underscore are also restricted. 2.8. I believe this is the last section. Layout of a C program. We can think of a C program as a series of tokens, group of characters that can't be split up without changing their meaning. Identifiers and keywords are tokens, so like operators like plus and minus, punctuation marks such as commas and semicolons, and string literals. For example, the statement printf, quote, height, colon, space, %d, \n, quote, and insert the height variable, consists of 7 tokens. Printf, the parenthesis, height, and that guy. Gotcha. Tokens 1 and 5 are identifiers, so the print and the height. Token 3 is a string literal, and tokens 2, 4, and 6 are punctuation. The amount of space between tokens in a program isn't critical in most cases. At one extreme, tokens can be crammed together with no space between them at all, except where this would cause 2 tokens to merge into a third token. For example, we could delete most of the space in the Celsius.c program of the section 2.6, provided that we leave space between tokens such as int and main, and between float and Fahrenheit. So you could cram all of this together like this. In fact, if the page were wider, we could print the entire main function on a single line. We can't put the whole program on one line though, because each pre-processing directive requires a separate line. Compressing programs in this fashion isn't a good idea. In fact, adding spaces and blank lines to a program can make it easier to read and understand. Fortunately, C allows us to insert any amount of space, blanks, tabs, and new line characters between tokens. This rule has several important consequences for program layout. Statements can be divided over any number of lines. The following statement, for example, is so long that it would be hard to squeeze into a single line. Space between tokens makes it easier for the eye to separate them. For this reason, I usually put a space between and after each operator. I also put a space after each comma. Some programmers go even further, putting spaces around parentheses and other punctuation. Indentation can make nesting easier to spot. For example, we should indent declarations and statements to make it clear they're nested inside main. Blank lines can divide a program into logical units, making it easier for the reader to discern the program structure. A program with no blank lines is hard to read as a book with no chapters. The Celsius.c program on section 2.6 illustrates several of these guidelines. Let's take a closer look at the main function in the program, where we have, this is our program, where we have nice spaces between our different lines. We have spacing in between our operators. First, observe how the space around equals, minus, and star make these operators stand out. Second, notice how the indentation of the declarations, right, and statements make it obvious that they belong to main. Finally, note how blank lines divide main into 5 parts. 1. Declaring the Fahrenheit and Celsius variables. 2. Obtaining the Fahrenheit temperature. 3. Calculating the value of Celsius. And 4. Printing the Celsius temperature. And 5. Returning the operating system. While we're on the subject of the program layout, notice how I placed the bracket tokens underneath main and put the matching bracket on a separate line aligned with the opening bracket. Putting the closing bracket on a separate line allows us to insert or delete statements at the end of the function. Aligning it with the opening makes it easy to spot the end of the main. Who's that? Hey, Foaz, thanks so much for the sub on YouTube. Appreciate you so much. You're awesome. Thank you. We're almost to, we're 2 subs away from 40-50 here. So thank you guys so much for all the love. Putting the closing bracket on a separate line lets us insert or delete statements at the end of the function. Aligning it with the opening bracket makes it easy to spot at the end of the main. A final note. Although extra spaces can be added between tokens, it's not possible to add space within a token without changing the meaning of the program, causing an error. Writing float Fahrenheit Celsius or float Fahrenheit Celsius produces an error when the program is compiled. Putting a space inside a string literal is allowed, although it changes the meaning of the string. However, putting a new line character in a string, in other words, splitting the string over 2 lines, is illegal. Continuing a string from one line to the next requires a special character. Continuing a string from one line to the next requires a special technique that we'll learn in a later chapter. Nice. Okay, so we have Q&A here, and then we have exercises. So I'm going to read the Q&A, and then we'll tackle the exercises and finish up the notes probably tomorrow. And that'll be a nice 2-day session on chapter 2, and then we'll move on. Okay. Q&A. What does GCC stand for? The answer. GCC originally stood for the GNU-C compiler and now stands for GNU Compiler Collection because the current version of GCC compiles programs written in a variety of languages, including Ada, C, C++, Fortran, Java, and Objective-C. Okay, so what does the GNU stand for? GNU stands for GNU, not Unix. And it's pronounced, GNU, by the way. GNU is a project of the Free Software Foundation as an organization set up by Richard M. Stallman as a protest against the restrictions of the licensed Unix software. According to its website, the Free Software Foundation believes that users should be free to run, copy, distribute, study, change, and improve software. The GNU project has rewritten the traditional Unix software from scratch and made it publicly available at no charge. GCC and other GNU software are GCC and other GNU software are critical. Oh my gosh. GCC and other GNU software are crucial to Linux. Linux itself is only the kernel of an operating system, the part that handles program scheduling and basic I/O services. The GNU software is necessary to have a fully functioning operating system. For more information on GNU project, visit www.gnu.org. That's cool. I didn't know that. What's the big deal about GCC anyways? GCC is significant for many reasons, not least the fact that it's free and capable of compiling a number of languages. It runs under many operating systems and generates code for many different CPUs, including all of the widely used ones. GCC is the primary compiler for many Unix-based operating systems, including Linux, BSD, and Mac OS, and it's used extensively for commercial software development. For information about GCC, visit gcc.gnu.org. How good is GCC at finding errors in programs? GCC has various command line options that control how thorough it checks programs. When these options are used, GCC is quite good at finding potential trouble spots in a program. Here are some of the more popular options. -wall causes the compiler to produce warning messages when it detects possible errors. -w can follow by codes for specific warnings. -wall means all -w options should be used in conjunction with -o for maximum effect. -w issues additional warning messages beyond those produced by -wall. -pedantic issues all warnings required by C standard, causing programs to use non-standard features to be rejected. -ANSI turns off features of GCC that aren't standard C and enables a few standard features that are normally disabled. dash standard or dash std equals C89 and dash std equals C99 specifies which version of the C compiler to use to check the program. These options are often used in combination. GCC-O, big O dash wall dash W dash pedantic dash ANSI dash std equals C99 dash O pun dash C. Why is C so terse? It seems as though programs would be more readable if C used begin and end instead of these brackets, integer instead of int, and so forth. Legend has it that the brevity of C programs is due to the environment that existed in Bell Labs at the time the language was developed. The first C compiler ran on the DEC PDP-11, an early minicomputer. Programmers used a teletype, essentially a typewriter connected to a computer, to enter programs and print listings. Because teletypes were very slow, they could print only 10 characters per second. Minimizing the number of characters in a program was clearly advantageous. In some C books, the main function ends with exit 0 instead of return 0. Are these the same? When they appear inside main, these statements are indeed equivalent. Both terminate the program, returning the value of 0 to the operating system. Which one to use is mostly a matter of taste. What happens if a program reaches the end of the main function without executing a return statement? The return statement isn't mandatory. If it is missing, the program will still terminate. In C89, the value returned to the operating system is undefined, and in C99, if main is undeclared, to return an in C99, if main is declared to return an int, as in our examples, the program returns 0 to the operating system. Otherwise, the program returns an unspecified value. Question: does the compiler remove a comment entirely or replace it with blank space? Answer: some old C compilers delete all the characters in each comment, making it possible to write this and to have the compiler interpreted as this. According to the C standard, however, the compiler must replace each comment by a single character, so this trick doesn't work. Instead, we'd end up with the following illegal statement. It replaces the comment by a single space character. How can I tell if my program has an unterminated comment? If you're lucky, the program won't compile because the comment has rendered the program illegal. If the program does compile, there are several techniques that you can use. Stepping through the program line by line with a debugger will reveal if any lines are being skipped. Some IDEs display comments in a distinctive color to distinguish them from the surrounding code. If you're using it in such an environment, you can easily spot unterminated comments since program text will have a different color if it's accidentally included in a comment. A program such as the lint can also help. Remember, lint was a tool that was used to kind of pick up the fluff. Is it legal to nest one comment inside another? Old style comments can't be nested. For example, the following code is illegal. The opening symbol on the second line matches the opening symbol on the the closing symbol on the second line matches the opening symbol on the first line, so the compiler would flag the closing symbol on the third line as an error. C's prohibition against nested comments can sometimes be a problem. Suppose we've written a long program containing many short comments. To disable a portion of the program temporarily during nesting, say, our first impulse is to comment out the offending lines with this. Unfortunately, this method wouldn't work if the lines contain old style comments. C99 comments, those begin with // can be nested inside the old comments. However, another advantage is to use this kind of comment. In any event, there's a better way to disable portions of a program, as we'll see later. Question: where does the float type get its name? Float is a short for floating point. Float is short for floating point, a technique for storing numbers in which the decimal point floats. A float value is usually stored in two parts: the fraction and the exponent. The number 12.0 might be stored as 1.5 times 2 to the power of 3, for example, where 1.5 is the fraction and 3 is the exponent. For some programming languages call this type real instead of float. Why do floating point constants need to end with the letter F? For the full explanation, see Chapter 7. Here's the short answer. A constant that contains a decimal point but doesn't end with F has type double, short for double precision. Double values are stored more accurately than float values. Moreover, double values can be larger than float values, which is why we need to add the letter F when assigning to a float variable. Without the F, a warning will be generated, or may be generated, about the possibility of a number being stored into a float variable that exceeds the capacity of the variable. Question: is it really true that there's no limit on the length of the identifier? Yes and no. C89 standard says that identifiers may be arbitrarily long. However, compilers are only required to remember the first 31 characters, 63 characters in C99. Thus, if two names begin with the same 31 characters, a compiler might be unable to distinguish them. To make matters even more complicated, there are special rules for identifiers with external linkage. Most function names fall into this category. Since these names must be made available to the linker, and since some older linkers can handle only short names, only the first 6 characters are significant in C89. Moreover, the case of letters may not matter. As a result, capital A, B, C, D, E, F, G, and lowercase a, b, c, d, e, f, h might be treated as the same name. In C99, the first 31 characters are significant, and the case of the letters is taken into account. Most compilers and linkers are more generous than the standard, so these rules aren't a problem in practice. Don't worry about making identifiers too long, worry about making them too short. How many spaces should I use for indentation? That's a tough question. Leave it too little space and the eye has trouble detecting indentation. Leave too much and the lines run off the screen or page. Many C programmers indent nested statements 8 spaces, 1 tab stop, which is probably too much. Studies have shown that the optimum amount of indentation is 3 spaces, but many programmers feel uncomfortable with a number that aren't a power of 2. Nerds. Although I normally prefer to indent 3 or 4 spaces, I'll use 2 spaces in this book so that the programs will fit in the margins. All right, and now we're on to the exercises here. So I'm going to complete the exercises tomorrow as well as go back through the, well, there's quite a few exercises, so hopefully we can complete them. And then go back through our notes and complete, a pass through, just going back and getting some definitions and such. I think will help kind of solidify the entire chapter because it was a little bit of a longer one. I think it was like about 25 or so pages, 20 pages we read. So 20 probably. So let's get caught up on some chats here. I like to think the star dereference operator follows the memory address and sees what's inside. But macOS replaced the GCC with Clang as default. Clang is also available on Linux though. Hey Santosh, that's good to know, Blasto. Foaz, what is my aim? I'm not sure what you mean by that. My aim? I'm just learning. Hey, Abhinav, how's it going? Why are you learning C? So, for those that are new, my name is Michael. I have a degree in human biology and a minor in chemistry. I'm 26 years old, graduated back in 2021 from college, and I work as a professional biochemist or a formulation chemist for a biotech company, and I make and manufacture and formulate biological controls. And I'm also been programming programming it at work more and more now, and I've been teaching myself how to program to develop tools for my team to optimize our processes and such. I'm pretty fluent in Python for the moment and have the ability to code up some pretty cool scripts in Python that we've been able to do for the past year and a half. But now we are diving further into more lower level programming and probably the hardware stuff. So I want to kind of start to expand my knowledge in just computer science in general and just become a more well-rounded computer scientist as well as programmer and physical scientist. So I appreciate you guys being here and joining me. We stream and teach ourselves computer science and programming almost every single day live here on the channel, completely transparent. Pretty much everything I do programming-wise is live here on the channel. So if you guys are interested in learning and holding yourself accountable, and whether it be in your homework, or if you're a student, or just learning independently, this is a great place to be. Thank you guys so much for being here. This is awesome. Um, all right. Cool. So yeah, I will go back through these notes and we will polish these up. They can be found on my GitHub, linked down in the description below if you would like to access them. But this was the entire reading of chapter 2 of, let me go back up to the chapter title here. All right, you guys, this was the entire reading of chapter 2, C Fundamentals, from C Programming, A Modern Approach, second edition by K.N. King. Again, we're going to go back through the notes at a later date and polish them up. You can find them in my GitHub link down below, but I appreciate you guys being here. If you enjoyed the kind of audiobook reading of this out loud, please leave a thumbs up, and thank you guys so much for being here. I'll see you next time in chapter 3. All right, let's stop that recording. Okay, cool. Nice. Oh boy, man, I got like a headache from talking so much though, you guys. Oh boy. Elemental says, hello, I got a question for you. I might ask this in an interview if Python was relevant. How many types exist in Python? Types? Well, there's a lot of different types in Python because Python you have like many different types of objects and stuff like that. I mean, you can have like dict and you can have list and all these other different types. Python is like an object-based language, right? So I think there's probably maybe some more to your question that you might be alluding to rather than maybe the basic types. It's kind of more of a trick question, maybe. Could it be like, I guess that would be maybe my unofficial answer without like maybe looking into it more. Like, I don't know. I don't have a number off the top of my head because there are quite a lot of different types in Python. Of type tuple, of type dict, type list, type. You can create obviously your own objects, your own whatever. Cool. Anyways, I appreciate you guys being here. You guys have any tips or pointers for what we read today? But we're gonna go back through at a later date. Where am I from? I'm from United States here. We're on the West Coast. Currently live in the old California, though. Thank you guys so much for being here. I appreciate you guys joining me on this stream. If you guys enjoyed it, please leave a like and subscribe so I can see you guys next time. I have a Discord link down below, which is why, or where I completely like compile all of my resources. So if you guys would like to get access to all of my resources, from the books I read to the courses I take to every kind of to leak code problems I solve to little stock informations and stuff I share, it's all in my Discord completely for free. I don't charge a single cent to anybody. I don't charge a single cent for any sort of these resources. I don't even have like a channel membership or anything, you guys. So I really try my best to provide all this programming content for you guys for free because I really think that well, I've kind of been proving here that you can learn programming somewhat and by just online resources or free resources, obviously. And then so thank you guys so much for being here, and I appreciate you guys joining me. And we're going to continue doing this tomorrow. Thank you guys. I'll see you guys tomorrow. Bye.